Chapter 1. The Secret That Changes Everything. What if I told you that everything you learned in school about human history was wrong? What if the story we've been told about when technology first appeared on Earth is just the beginning of something much bigger and much more mysterious? Tonight, as you drift off to sleep, I want to take you on a journey that will change how you think about our planet forever. We're going to explore a possibility so incredible that it challenges everything we thought we knew about intelligence, technology, and time itself. Picture this. You're walking through a museum looking at dinosaur bones that are 150 million years old. The tour guide tells you that these creatures ruled the Earth long before humans ever existed, long before the first stone tool was ever made, long before fire was discovered. But what if that guide was wrong? What if technology didn't begin with us at all? What if something else had been here first? Something that built, created, and shaped the world millions of years before the first human ever took a breath. This isn't science fiction. This is a question that real scientists are now asking, and the answers might surprise you. Think about how much we don't know about our own planet. We've explored more of the surface of Mars than we have of our own ocean floors. We've mapped distant galaxies but haven't seen most of what lies beneath our feet. In all that unknown space, in all those millions of years of Earth's history, could something incredible be hiding? The traditional story goes like this. First, there was nothing but rocks and water. Then, simple life appeared. Much later, dinosaurs ruled the world. After they disappeared, mammals took over. Finally, humans showed up and invented technology. It's a neat, clean timeline that makes sense. But what if it's not complete? What if there are chapters missing from this story? What if intelligence and technology have appeared on Earth not once, but multiple times, separated by millions of years? What if we're not the first, but just the latest in a long line of civilization? Where are their machines? Where are their monuments? These are good questions, and we'll explore them tonight. But first, let me ask you something else. If our civilization disappeared tomorrow, what would be left after 100 million years? What would future archaeologists find of New York City, of the internet, of space shuttles and smartphones? The answer might surprise you. Almost nothing. Buildings crumble, metal rusts, glass breaks. Even our most permanent monuments would eventually turn to dust. Over millions of years, continents drift, oceans rise and fall, and the very surface of the Earth is recycled. Almost everything we've built would vanish completely. But not everything disappears. Some traces remain, hidden in chemistry, buried in rock layers, preserved in ways we're only beginning to understand. And if we know where to look, if we know what to look for, we might find clues to civilizations that lived and died long before the first dinosaur ever hatched. This isn't just about ancient aliens or fantasy stories. This is about real science, real discoveries, and real mysteries that are challenging how we think about Earth's history. Scientists have given this idea a name, the Silurian hypothesis. It asks a simple but profound question. If a technological civilization existed millions of years before humans, would we be able to detect it today? The answer is more complex than you might think, and as we explore it tonight, you'll discover that our planet might be far stranger and more mysterious than we ever imagined. So settle in, get comfortable, and prepare to question everything you thought you knew about technology, time, and our place in the universe. Because what you're about to learn might just change how you see the world forever. Are you ready to discover the secret that could rewrite history itself? Let's begin this incredible journey together. Chapter 2. What we're really missing. Before we dive into the evidence and mysteries, we need to understand just how little we actually know about Earth's past. This might be the most important part of our entire journey tonight, because it shows us why missing entire civilizations isn't just possible, it's almost inevitable. Let me start with a question that might blow your mind. What percentage of all the animals completely within days or weeks? Scavengers eat the flesh. Bacteria break down what's left. Rain and wind scatter the bones. For fossilization to happen, the animal has to be buried quickly, usually by mud, sand, or volcanic ash, before decomposition is complete. Even then, only the hardest parts have a chance of surviving. Bones, teeth, shells, these might become fossils. But soft tissues, wood, plant fibers, anything organic, almost always disappears forever. And even when fossilization does occur, the fossil has to survive for millions of years without being destroyed by erosion, earthquakes, or the gradual recycling of rock through Earth's crust. It's like winning the lottery multiple times in a row. The odds are so small that fossilization is actually an extraordinary accident, not a normal process. Now, if this is true for animals, creatures that lived in huge numbers across the entire planet, what does it mean for technology? If a civilization existed millions of years ago, what are the chances that any of their buildings, tools, or machines would survive? Let me put this in perspective. The Great Pyramid of Giza was built only 4,500 years ago, and it's already showing serious signs of wear. The stones are cracking, the surface is eroding, and without constant maintenance, it would crumble within a few thousand years. That's for a structure specifically designed to last forever, built from some of the most durable materials available. Now imagine trying to find traces of a civilization that existed not thousands, but millions of years ago. Their buildings would be gone, their tools would have rusted away, their roads would have been ground to dust by wind and rain. But here's where it gets even more mind-bending. The surface of our planet is constantly changing in ways most people never think about. The ground beneath your feet isn't permanent. It's moving, shifting, and recycling itself through a process called plate tectonics. The ocean floor, which covers most of our planet, is never older than about 200 million years. That's because it's constantly being created at underwater mountain ranges and destroyed at deep ocean trenches. Any evidence of ancient civilizations that might have existed on the sea floor. Why haven't we found ancient civilizations? The real question is, how could anything that old possibly survive? And yet, despite all these challenges, some things do survive. A footprint in mud can be preserved for hundreds of millions of years if it's buried quickly and left undisturbed. The impression of a leaf can remain in stone long after the forests that created it have turned to coal. These rare survivals show us that preservation is possible, even over vast periods of time. It's incredibly unlikely, but it can happen. And if natural things like footprints and leaves can survive for hundreds of millions of years, then it's at least theoretically possible that artificial things, tools, structures, even machines, could survive too, under the right circumstances. This is why scientists take the possibility of ancient technology seriously, even if they think it's unlikely. We're not looking for entire cities or fleets of spaceships. We're looking for fragments, for traces, for tiny clues that might have beaten the incredible odds and survived the passage of deep time. Could such traces exist? Could we have already found them without realizing what they were? These are the questions that keep researchers awake at night, searching through museum collections and geological surveys, looking for anomalies that might just rewrite history. As we'll see next, the story of life on Earth is far older and stranger than most people realize. And in that vast, mostly unknown history, there's room for possibilities that challenge everything we think we know about intelligence and technology. Chapter 3. The mystery beneath our feet. Now I want you to imagine something that might sound impossible. Picture Earth not as we know it today, but as it was 300 million years ago. The world was so different back then that you wouldn't recognize it as the same planet. Giant ferns towered overhead like skyscrapers, some reaching heights of 100 feet or more. Dragonflies with 2-foot wingspans buzzed through humid air that contained twice as much oxygen as today's atmosphere. Millipedes longer than school buses crawled through steamy swamps. This was the Carboniferous period, and it was more alien. All that vast expanse of time, with all those different environments and all those millions of species. Is it really impossible that intelligence might have emerged? Now, I'm not talking about T-Rex building spaceships. The dinosaurs we know about don't show signs of tool use or technology. But what about the creatures that came before them? What about the periods we know almost nothing about? Here's something that might surprise you. We know more about some distant galaxies than we do about certain periods of Earth's own history. There are entire epochs, lasting millions of years, where our knowledge is almost blank. Whole ecosystems have come and gone without leaving enough evidence for us to understand how they worked or what they looked like. Take the Ediacaran period, about 600 million years ago. We know that strange, soft-bodied creatures lived in Earth's oceans during this time. Some of them were huge, larger than dinner plates. Some had bizarre shapes, unlike anything alive today. But because they had no hard parts, very few fossils survived. We have only tantalizing glimpses of what might have been an entire world of life forms. Or consider the Boring Billion, a period from about 1.8 billion to 800 million years ago, when evolution seemed to slow down. We call it boring because so little appears to have happened. But what if that's just because we can't see what was really going on? What if amazing things were happening that left no trace we know how to recognize? This brings us to a crucial point. Absence of evidence is not evidence of absence. Just because we haven't found something doesn't mean it never existed. It might mean we haven't looked in the right places, or we haven't recognized what we're seeing. Consider this example from our own time. In 1938, scientists discovered a fish called the coelacanth off the coast of South Africa. This was shocking, because coelacanths were supposed to have gone extinct 66 million years ago. For all those millions of years, this extinct fish had been swimming around in deep ocean waters, completely unknown to science. If a large fish can remain hidden for 66 million, like having a library where 80% of the books are locked away, and the other 20% gets completely replaced with new books every few 100 million years, how much of the story could you piece together from what's left? This is the reality of studying Earth's deep past. We're working with fragments of fragments, trying to reconstruct billions of years of history from scattered clues. Most of the evidence has been destroyed by time, weather, and the planet's own geological recycling. But those fragments that do survive can be incredibly revealing. Sometimes a single fossil can tell us about an entire ecosystem. Sometimes a thin layer of rock can reveal a mass extinction that changed the course of life on Earth. This is why every anomaly matters. When we find something that doesn't fit the expected pattern, a strange object in an old rock layer, an unusual chemical signature, a fossil that seems out of place. It might be telling us something important about a lost chapter of Earth's history. Most of these anomalies turn out to have natural explanations, but not all of them do. And in those few cases where the explanation remains unclear, we glimpse the possibility that our understanding of the past might be incomplete. As we'll explore next, there's actually a formal scientific framework for thinking about this possibility. Scientists have given it a name and are seriously investigating whether technological civilizations could have existed in Earth's deep past without leaving obvious traces. The question isn't whether we should believe such civilizations existed. The question is whether we would even know how to recognize them if they had. Chapter 4: When Giants Walked Before Giants. Let me take you even further back in time, to periods so ancient that they make the dinosaurs look like newcomers. We're going to explore eras when Earth was populated by creatures so strange and wonderful that they seem like something from an alien world. About 500 million years ago, during what scientists call the Cambrian explosion, life suddenly became incredibly diverse. In a relatively short period of geological time, creatures with shells, eyes, claws, and complex body plans appeared in the fossil record. It was as if nature was experimenting with every possible design for living things. One of the most like a living pine cone. There was hallucigenia, so bizarre that scientists originally reconstructed it upside down and backwards. These weren't simple creatures. Many had complex behaviors, sophisticated sensory systems, and intricate ecological relationships. They built structures, modified their environments, and competed with each other in ways that required considerable intelligence, at least by the standards of their time. Now fast forward about 200 million years to the Devonian period, often called the Age of Fishes. This was when vertebrates really began to diversify and spread. Some fish grew to enormous sizes. Dunkleosteus had jaws powerful enough to bite through sharks. Others developed the ability to breathe air and venture onto land, eventually giving rise to all land vertebrates, including us. But what really captures the imagination is thinking about the possibilities during these vast stretches of time. Evolution had hundreds of millions of years to work with. It produced creatures with crystalline eyes, electrical senses, chemical communication systems, and structural engineering skills that still amaze scientists today. If evolution could produce such sophisticated solutions to survival challenges, what else might it have been capable of? We tend to think of intelligence as a recent development, something that only appeared with mammals and birds. But what if that's not true? What if intelligence, in forms we might not even recognize, has been emerging and disappearing throughout Earth's history? Consider cephalopods, octopuses, squids, and their relatives. These creatures evolved intelligence completely independently from vertebrates. Their nervous systems are organized differently from ours. Their problem-solving strategies are alien to us, yet they demonstrate remarkable intelligence. Octopuses use tools, solve puzzles, and show individual personalities. Some species communicate with complex color patterns that function like a visual language. If octopuses can evolve intelligence in just a few 100 million years, starting from a completely different biological foundation than ours, what might have been possible given more time? What might have developed during those vast periods we know almost nothing about? There's another factor to consider: environmental pressure. Intelligence tends to evolve when creatures face complex challenges that can't be solved by simple behaviors. Social cooperation, predator avoidance, food acquisition in difficult environments. All of these can drive the evolution. Flexible and intelligent. They would have needed to solve problems, modify their behavior, and perhaps even modify their environment to survive. Now, here's where the story gets really interesting. We know that some creatures have been modifying their environment for hundreds of millions of years. Coral reefs are structures built by tiny animals that have shaped entire ocean ecosystems. Termite mounds are architectural marvels with sophisticated ventilation systems. Beaver dams change the flow of rivers and create new wetland habitats. If simple creatures can build structures that persist for thousands of years and change entire landscapes, what might more intelligent creatures have been capable of? What if some ancient species learned to work with materials we don't recognize as technology? What if they built with organic compounds, living materials, or methods so different from ours that we wouldn't even recognize their constructions as artificial? This is where our human-centered view of technology might be limiting us. We think of technology as metal tools, electronic devices, and mechanical systems. But that's just one possible path for intelligence to take. An entirely different kind of intelligence might have developed entirely different solutions. Imagine creatures that learn to shape living coral into useful forms, or species that developed biological chemistry so sophisticated they could create materials stronger than our best alloys, or organisms that learn to harness energy sources we haven't even discovered yet. Such technologies might leave traces completely different from what we expect to find. Instead of metal artifacts, we might need to look for unusual biological structures, chemical signatures that don't occur naturally, or patterns in the geological record that suggest environmental manipulation on a large scale. This broader view of what technology might look like is crucial for understanding why ancient civilizations might be so hard to detect. If they existed, they might have been so different from us that we wouldn't recognize their achievements even if we found them. As we'll see next, this possibility has become serious enough that scientists have developed formal hypotheses to explore it. They're not just speculating, they're developing testable predictions about what evidence of ancient civilizations might look like and where we might find it. Chapter 5. The Scientists Who Dared. Playful name. This was serious science, published in a peer-reviewed journal and based on rigorous analysis of what civilizations actually leave behind. Now, Schmidt and Frank weren't claiming that ancient civilizations actually existed. They were asking a more fundamental question. How would we know if they had? What evidence should we look for? And what does the search teach us about our own civilization's impact on the planet? This might seem like an academic exercise, but it has profound implications. As we search for life on other planets, we need to know what signs of intelligence actually look like over geological timescales. If we can't recognize the traces of hypothetical ancient civilizations on our own planet, how can we hope to find them elsewhere in the universe? The researchers started by acknowledging what we've already discussed. Physical artifacts like buildings, tools, and machines wouldn't survive millions of years. So they focused on what might persist: chemical and geological signatures that could remain locked in rock layers long after the civilizations that created them had vanished. Think about what our current civilization is doing to the planet. We're burning fossil fuels, which releases carbon with a distinctive chemical signature. We're creating synthetic materials like plastics that don't occur naturally. We're changing the composition of the atmosphere, the chemistry of the oceans, and the diversity of life on Earth. All of these changes are being recorded in sediments that are forming right now. Millions of years from now, future geologists will find a thin layer of rock that contains unusual amounts of carbon, synthetic compounds, and evidence of a massive extinction event. They'll call it the Anthropocene boundary, the geological signature of human civilization. But here's the crucial question. Would they recognize it as evidence of intelligence? Or would they interpret it as a natural disaster, like a massive volcanic eruption or asteroid impact? Schmidt and Frank realized that this uncertainty works both ways. When we look at Earth's geological history, we see many sharp boundaries that mark sudden changes in chemistry, climate, and life. We usually interpret these as natural events. But what if some of them were actually the signatures of ancient civilizations? For example, there was a mysterious event about 56 million years ago. Distinguish between natural and artificial causes when looking at events millions of years in the past. The Silurian hypothesis forced scientists to think more carefully about what evidence of intelligence actually looks like. It's not just about finding metal objects or stone tools. It's about understanding how civilizations change the fundamental chemistry and energy balance of their planet. This research has already led to new insights about our own impact on Earth. By studying how civilizations leave traces in the geological record, we're learning more about how human activity will be remembered in the distant future. Our plastic pollution, our nuclear isotopes, our changes to atmospheric chemistry. All of these will remain detectable for millions of years. But the hypothesis also opens up new possibilities for finding ancient intelligence. Instead of looking for artifacts, we might look for unusual chemical spikes in rock layers, isotope ratios that don't match natural processes, or patterns of extinction and recovery that suggest environmental manipulation. Some researchers have even started re-examining known geological anomalies with this new perspective. There are several periods in Earth's history where the chemical and biological record shows rapid, dramatic changes that are difficult to explain through natural processes alone. For instance, the Great Oxygenation Event, about 2.4 billion years ago, completely transformed Earth's atmosphere and caused a mass extinction of organisms that couldn't tolerate oxygen. Most scientists think this was caused by the evolution of photosynthetic bacteria, but the exact mechanism and timing are still mysterious. Could intelligence have played a role in some of these ancient environmental changes? It's extremely unlikely, but the question is now at least scientifically legitimate. The Silurian hypothesis has given researchers a framework for thinking about these possibilities without abandoning scientific rigor. This represents a fundamental shift in how we think about intelligence and technology. Instead of assuming that advanced civilizations must leave obvious physical traces, we're learning to look for subtler signatures, chemical fingerprints that might persist long after all other evidence has vanished. As we'll explore next, this new way of thinking has led researchers to take a fresh look at some of the anomalous objects and formations that have puzzled scientists for decades. Objects that seem too strange to be natural, but too isolated. Around the world, people have discovered objects that seem to defy explanation. Things that appear artificial, but are found in rock layers supposedly millions of years old. These discoveries have sparked fierce debates between mainstream scientists and researchers who believe they might be evidence of ancient technology. Tonight, I want to take you through some of the most famous cases and let you decide what to think. Let's start with one of the most controversial discoveries of the 20th century, the so-called 300-million-year-old screw. This story begins in the 1990s, when Russian researchers claimed to have found a tiny metallic object embedded in a piece of rock from the Moscow region. The object was only about a centimeter long, but it looked remarkably like a modern screw, complete with clearly visible threads spiraling around its length. The rock itself was believed to date back to the Carboniferous period, about 300 million years ago. This was long before, not just humans, but even dinosaurs. If the dating was correct, then this object represented technology from a time when the most advanced life forms on Earth were probably insects and early amphibians. Photographs of the object spread rapidly, first in Russian publications, then across the early internet. To many observers, it looked unmistakably artificial. The threads were too regular, too precise to be natural. Screws are human inventions. Nature doesn't make threaded fasteners. Believers in ancient technology seized on this discovery as proof that advanced civilizations had existed millions of years before humans. Some suggested it might be evidence of time travel, alien visitation, or lost human civilizations that had been erased from the geological record. But skeptics had different explanations. The most common suggestion was that the screw was actually a fossilized crinoid stem. Crinoids are marine animals related to starfish and sea urchins. They have long, segmented stalks that can look remarkably like screws when preserved as fossils. These creatures were abundant during the Paleozoic era, which matches the supposed age of the rock. The problem is that, without detailed scientific analysis of the original object, it's impossible to know for certain what it really is. The initial reports weren't accompanied by rigorous testing, and much of what we know comes from photographs and second-hand descriptions. This designs. When we see something that looks like human technology, our first instinct is to assume it is human technology, even when found in impossible contexts. This psychological tendency is called pareidolia, the tendency to perceive meaningful patterns in random information. It's why we see faces in clouds, animals in rock formations, and familiar objects in ambiguous shapes. It's a useful survival trait that helps us quickly identify important things in our environment, but it can also lead us astray when we're trying to interpret anomalous discoveries. However, dismissing every unusual object as pareidolia has its own risks. Throughout history, many genuine discoveries were initially dismissed as impossible or misidentified. The first dinosaur fossils were thought to be dragons. Meteorites were considered mythical until the early 1800s. Giant squid were dismissed as sailors' tales until specimens were finally captured. So when we encounter objects like the Russian screw, we need to balance healthy skepticism with open-minded inquiry. Most anomalous objects probably do have natural explanations, but that doesn't mean all of them do. Let me share another intriguing case from South America. In the 1960s, archaeologists working in Peru discovered what appeared to be surgical instruments in ancient Inca graves. The objects included what looked like bone saws, scalpels, and even instruments that resembled modern forceps. But first, researchers assumed these were just ceremonial objects or primitive tools. But when they examined skulls from the same sites, they found evidence of successful brain surgery, trepanation procedures that had healed completely, showing the patients had survived the operations. This discovery forced archaeologists to radically revise their understanding of ancient medical knowledge. The Inca and their predecessors had developed surgical techniques sophisticated enough to perform brain operations, with survival rates that were actually better than those achieved in European hospitals of the same period. The point is that human ingenuity and technological achievement can appear much earlier and in more unexpected places than we initially realize. If this is true for well-documented human cultures, how much more might it be true for isolated discoveries? Most anomalous objects fail one or more of these tests, but a few continue to resist easy explanation, keeping alive the possibility that our understanding of the past might be incomplete. As we'll see in our next chapter, one of the most famous of these resistant cases involves a simple hammer that has sparked decades of debate about the nature of time, preservation, and what we think we know about human history. Chapter 7. The Hammer That Broke History. In 1936, a couple named Max and Emma Hahn were walking near the small town of London, Texas, when they noticed something unusual protruding from a rock formation along a creek. It looked like a piece of old wood, but it was somehow embedded in solid stone. Curious, they pried the rock loose and took it home. What they had found would become one of the most controversial archaeological discoveries of the 20th century: a hammer with an iron head and wooden handle, apparently encased in limestone that geological surveys suggested could be over 100 million years old. At first glance, this seems impossible. The hammer looks like a typical 19th century tool, the kind of thing a farmer or carpenter might have used. The iron head shows signs of corrosion, and the wooden handle is partially petrified. It's clearly a human-made object. But if the rock surrounding it really is 100 million years old, then humans were making iron tools long before they were supposed to have evolved. For believers in ancient technology, the London hammer became a smoking gun. proof that conventional history was wrong, and that advanced civilizations had existed far earlier than anyone imagined. The hammer was displayed in a small museum, and photographs of it circulated widely, especially after the internet made it easy to share images around the world. But mainstream geologists and archaeologists were skeptical. They pointed out several problems with the ancient age claim. First, the rock surrounding the hammer wasn't necessarily as old as it appeared. Limestone can form relatively quickly under the right conditions through a process called concretion, where minerals in groundwater gradually cement around an object. This process can make a modern object appear to be embedded in ancient rock, when actually the rock formed around it. Carefully record the exact location or geological context. This makes it difficult for scientists to verify the age of the surrounding rock or understand how the hammer became embedded. So the most likely explanation is that the London hammer is a perfectly ordinary 19th century tool that became encased in mineral concretions, creating the illusion of extreme age. The hammer itself might be 150 years old, while the rock surrounding it could have formed in just decades or centuries. But here's what makes this case interesting from our perspective tonight. Even if the hammer is relatively modern, it illustrates how difficult it would be to recognize genuinely ancient technology if we found it. Think about it this way. If a simple 19th century hammer can spark decades of debate about its age and origin, how much harder would it be to identify and verify technology that really was millions of years old? How many potential artifacts might have been dismissed as natural formations or modern contamination without proper investigation? The London hammer also highlights the importance of proper scientific documentation. Without careful recording of where objects are found, what geological layers they come from, and what other materials are associated with them, it's nearly impossible to determine their true age and significance. This is why most scientists are skeptical of anomalous objects that aren't discovered during formal archaeological excavations. Too many factors can contaminate the evidence or make it impossible to verify claims about age and origin. But the hammer story has another important lesson. It shows how powerful visual evidence can be, even when other evidence contradicts it. The image of a hammer embedded in stone creates an immediate emotional impact that's hard to shake, even after reading detailed explanations of how such embedding could occur naturally. This is why anomalous objects often develop passionate followings, despite scientific skepticism. They tap into our sense of wonder and our desire to believe that history might be more mysterious than we've been told. They represent possibilities that are emotionally appealing, even when they're not scientifically supported. The London hammer reminds us that the line between natural and artificial, between ancient and modern, can be blurrier than we expect. It requires extraordinary evidence and careful analysis. As we'll see, not all mysterious objects are so easily explained. Spheres from another time. Deep in the mines of South Africa, workers have been finding something that shouldn't exist. For decades, miners extracting pyrophyllite, a soft rock used in industrial applications, have uncovered small metallic spheres embedded in the stone. These aren't just any spheres. Many are perfectly round. Some have parallel grooves carved around their circumference, and they're found in rock formations that date back nearly 3 billion years. If that dating is correct, these objects are among the oldest anomalies ever discovered, created at a time when Earth's atmosphere barely contained oxygen, and the most complex life forms were single-celled bacteria. Yet some of these spheres look as if they were manufactured yesterday. The spheres vary in size, from marble-sized to several centimeters across. The most intriguing ones have 3 parallel grooves running around their equator, so precise and regular that they look like they were made on a lathe. Their metallic composition and smooth finish have led some researchers to suggest they must be artificial, products of some unknown technology from Earth's earliest history. For believers in ancient civilizations, the Klerksdorp spheres represent the ultimate proof. Here are objects that appear manufactured, found in rock formations that predate not only human civilization, not only complex life, but even the oxygen atmosphere that makes our kind of life possible. If these spheres really are artificial, they would push the origin of technology back billions of years, to an era when Earth was almost unrecognizable. The implications would be staggering. Who or what could have created precision-machined objects when Earth was a hostile world of toxic atmosphere and boiling seas? Were they made by some form of life so alien to us that we can't even imagine what it might have looked like? Or do they represent visits from elsewhere? Ancient astronauts who left calling cards in Earth's earliest rocks. But as with all anomalous objects, the reality is more complex than it first appears. Geologists who have studied the spheres offer a different explanation. They suggest that these objects are not artificial at all. Conditions could have created distinct layers that, when weathered, appear as parallel lines around the sphere's surface. The metallic appearance is also not necessarily artificial. The spheres are composed primarily of pyrite and hematite, iron-bearing minerals that can form naturally and have a metallic luster. Under certain conditions, these minerals can create objects that look remarkably like manufactured metal items. Moreover, the rock in which the spheres are found, pyrophyllite, is extremely soft. It can be scratched with a fingernail, which means that harder mineral inclusions could have formed within it at various times during its geological history. The spheres might be billions of years younger than the surrounding rock, even if they're still incredibly ancient by human standards. So which explanation is correct? Are the Klerksdorp spheres evidence of technology from Earth's earliest era? Or are they natural formations that happen to look artificial? The honest answer is that we don't know for certain. While the geological explanation is more plausible and doesn't require us to radically revise our understanding of Earth's history, it's not definitively proven. The spheres remain anomalous, objects that challenge easy categorization and continue to puzzle researchers. This uncertainty is part of what makes the spheres so fascinating. They exist at the boundary between the possible and the impossible, the natural and the artificial. They remind us that nature is capable of creating objects that mimic technology so closely that even experts can disagree about their origin. But they also illustrate a crucial point about anomalous objects. Extraordinary claims require extraordinary evidence. The suggestion that these spheres are 3-billion-year-old artifacts is extraordinary indeed. To support such a claim, we would need evidence that goes far beyond their appearance. We would need chemical analysis showing that their composition is impossible to achieve through natural processes. We would need clear signs of manufacturing techniques, tool marks, joints, assembly points that can't be explained geologically. We would need multiple examples from different locations showing consistent design features. Most importantly, we would need to find them in spheres, hailstones, pearls, and many mineral formations are naturally spherical. But the combination of perfect symmetry and regular grooves is more unusual, though not impossible through natural processes. The spheres also raise interesting questions about how we define artificial. If these objects were created by some form of life, but life so different from us that we can't recognize it as intelligence, would they be natural or artificial? The distinction becomes philosophically complex when we consider the vast scales of time and the possibility of forms of organization we don't understand. Regardless of their true origin, the Klerksdorp spheres serve an important function in our exploration tonight. They push us to question our assumptions about what's possible and what's natural. They remind us that the early Earth was a strange and hostile place, where conditions existed that we can barely imagine. And they illustrate why the search for ancient technology is so challenging. Even when we find objects that seem clearly artificial, natural explanations often exist. The line between natural and artificial blurs when we look across billions of years of Earth's history. As we'll see next, this blurring of boundaries is a common theme in all anomalous discoveries. The question isn't always whether something is natural or artificial. Sometimes the question is whether we can tell the difference. Chapter 9. What nature can't explain. As we've journeyed through these mysterious discoveries tonight, you might have noticed a pattern. Every anomalous object we've discussed, the supposed screw, the London hammer, the Klerksdorp spheres, has prompted the same debate. Is it natural or artificial? This debate reveals something profound about the challenge of recognizing ancient technology. The problem isn't just that physical objects decay over millions of years. The problem is that nature itself is such an accomplished engineer that it can create objects that look designed, intentional, and artificial. Consider some examples from our modern world. Walk along any beach and you might find stones worn perfectly smooth by waves, crystals that form with mathematical precision, or fossils preserved with incredible detail. Visit a canyon and you'll see rock formations that look like castles, bridges, or giant sculptures. Nature, intelligence leaves its mark on the world, and how we can recognize that mark when it's been obscured by time. Scientists have developed several criteria for identifying genuine artifacts, whether they're thousands or millions of years old. First, they look for complexity that can't be explained by natural processes. A simple sphere might form naturally, but a sphere with intricate internal mechanisms would be much harder to explain without intelligence. Second, they look for patterns that repeat in ways that suggest intentional design. One unusual object might be a coincidence, but multiple similar objects found in different locations would be more convincing. Natural processes can sometimes create regular patterns, but they usually show variation and imperfection that intelligence tends to avoid. Third, they look for materials or compositions that don't occur naturally, or that require specific knowledge and techniques to create. An alloy of metals that couldn't form under natural conditions, or a ceramic with properties that require controlled firing temperatures, would be strong evidence of intelligence. Fourth, they examine the context in which objects are found. Genuine artifacts are usually associated with other signs of intelligence: tools, waste products, modified environments, or chemical signatures that suggest intentional activity. Using these criteria, most of the famous anomalous objects we've discussed tonight fall short of proving ancient technology. They might look artificial, but they don't meet the rigorous standards needed to overturn our understanding of history. But here's where the story gets more interesting. While individual objects might not prove ancient civilizations, some researchers are looking at broader patterns that might be more convincing. Remember the Silurian hypothesis we discussed earlier? Instead of focusing on individual artifacts, it suggests looking for chemical and geological signatures that could persist much longer than physical objects. These signatures might be subtle, but they could be more reliable indicators of past intelligence. For example, if an ancient civilization had used large amounts of energy, it might have left behind unusual concentrations of certain elements in rock layers. If they had developed nuclear technology, isotopes that don't occur naturally might still be detectable. If they had engaged in... There are several periods in Earth's history where the chemical and biological record shows rapid, dramatic changes that are difficult to explain through natural processes alone. The Great Oxygenation Event, about 2.4 billion years ago, completely transformed Earth's atmosphere and caused a mass extinction. Most scientists attribute this to the evolution of photosynthetic bacteria, but the exact timing and mechanisms remain mysterious. The Cambrian explosion, about 540 million years ago, saw the rapid appearance of complex life forms with hard shells, eyes, and sophisticated behaviors. While clearly biological in origin, some aspects of this diversification are still not fully understood. More recently, the Paleocene-Eocene thermal maximum, about 56 million years ago, involved rapid warming and massive carbon release that some researchers find difficult to explain through known, natural processes alone. Now, I want to be very clear. There's no credible evidence that any of these events were caused by ancient civilizations. The scientific consensus is that they all have natural explanations, even if some details remain unclear. But the Silurian hypothesis has given us a framework for thinking about what such evidence might look like, if it existed. This shift in thinking, from looking for objects to looking for processes, might be crucial for understanding our planet's deep history. If ancient intelligence did exist, its most lasting legacy might not be buildings or tools, but changes to Earth's fundamental chemistry and energy systems. This brings us to an important realization. The search for ancient technology isn't really about finding proof of lost civilizations. It's about developing better methods for recognizing intelligence in the geological record, which has implications for understanding both our own impact on the planet and our search for life elsewhere in the universe. As we prepare to conclude our journey tonight, let's consider what all of this means for our understanding of Earth's history and our place in the cosmic story. Chapter 10. Messages written in stone. As our journey through deep time draws to a close, I want to leave you with some thoughts that might change how you see the world around you. We've explored so rare, so fragmentary, and so difficult to interpret that we might never recognize them with certainty. But this uncertainty works both ways. Just as we can't prove that ancient technology existed, we also can't prove that it didn't. The gaps in our knowledge are simply too vast, the destruction of evidence too complete for absolute certainty in either direction. This leaves us in a fascinating position. We live on a planet whose deep history remains largely mysterious. Beneath our feet lie billions of years of stories that we can barely begin to read. In that vast library of stone and sediment, almost every page has been lost or damaged beyond recognition. What we can read tells us that Earth has been home to countless experiments in life and intelligence. Evolution has produced crystalline eyes, electrical senses, chemical communication systems, and architectural achievements that still amaze engineers. If nature could accomplish so much that we recognize as sophisticated, what might it have achieved that we don't yet understand? The search for ancient technology, whether successful or not, has already taught us valuable lessons. It has forced us to think more carefully about what evidence civilizations actually leave behind. It has made us more aware of our own impact on the planet and how that impact will be remembered in the geological record. Most importantly, it has reminded us that intelligence might not be as rare or as recent as we often assume, whether it emerged once or multiple times on Earth, whether it exists elsewhere in the universe, whether it takes forms we would recognize or forms so alien we couldn't understand them. These questions remain open. The anomalous objects we've discussed tonight, the supposed screw, the London hammer, the Klerksdorp spheres, might all have natural explanations, but they serve an important function anyway. They remind us that nature is full of surprises, that our understanding of the past is incomplete, and that extraordinary possibilities sometimes hide in the most ordinary places. More than that, they represent something essentially human, our desire to believe that we're part of a larger story, that intelligence and creativity have been shaping the universe for far longer than our brief moment in cosmic history. This desire isn't just
the search for life elsewhere. The same chemical signatures that might reveal industrial activity in Earth's past could help us identify inhabited worlds around other stars. In this way, the seemingly abstract question of technology older than dinosaurs connects to some of the most practical challenges facing modern science. We're learning to read the signatures that intelligence leaves in the cosmos, preparing for discoveries that might reshape our understanding of life itself. So what should you take away from our journey tonight? First, that the world is far older and more mysterious than our everyday experience suggests. Second, that intelligence might be more common and more ancient than we've traditionally believed. Third, that the search for our origins, whether biological or technological, requires us to think in ways that stretch our imagination and challenge our assumptions. Whether you choose to believe in ancient civilizations or remain skeptical, I hope you'll carry with you a sense of wonder about the deep past and an appreciation for the vast scales of time and space that surround us. Every rock you walk on, every fossil you see in a museum, every layer of sediment exposed in a road cut represents millions of years of Earth's history. In those layers lie stories we're only beginning to learn to read. Stories of climates that came and went, species that rose and fell, and possibly intelligences that shaped the world long before us. The next time you look at an unusual rock, a strange formation, or an object that seems out of place, remember that you might be looking at a page from Earth's hidden history. Most of the time, that page will tell a natural story of wind, water, and geological processes. But sometimes, just sometimes, it might tell a different story entirely. And in that possibility, in that uncertainty, lies the magic that keeps us searching, wondering, and asking questions that push the boundaries of what we think we know. The universe is vast, time is deep, and the story of intelligence might be far older and more complex than we've ever imagined. As you drift off to sleep tonight, let your mind wander through those vast spaces and times, and remember that in a cosmos full of mysteries, almost anything is possible.